period of time from the late 20s, early 30s, where we knew absolutely nothing about genetics, to a point in 2016 where not only do we know quite a bit about it, but you're going to take some genes and do electrophoresis and cut DNA in pieces. If we still do the lab, I think we do this week, you're going to take jellyfish genes sometime this semester and put them inside bacteria and make bacteria glow in the dark. If you think about it, from knowing absolutely nothing to being able to manipulate genetic material and create new organisms inside that short time span is pretty significant. Especially when you consider most of the major work has only happened since the 50s. So it's a lot in a short amount of time. But what we're going to do is we're going to look at how we got here, look at the major players. We're not looking at the minor players. There were lots more players than this. But we're going to look at it. And if you're already sitting there saying, oh, geez, it's going to be the history class. History's so boring. We will spend time talking about industrial espionage and a woman scorned and et cetera, et cetera. So it'll be interesting. But we got to start somewhere. So we start with Griffith in 1928. And one of the interesting things about Griffith is he wasn't a researcher. Griffith was a physician. He was studying pneumonia. Late 20s, early 30s, pneumonia is a huge topic for research. And it still carries through even now. Some of you are young enough to do this, or old enough really to have done this. If it's the middle of winter and you jump out of the shower and you're running outside to do something and grandma's around, what does she usually yell at you? Grandma happy with you running out of the shower outside in December weather? No, what does she say? Exactly. Get your butt in this house, you're going to catch pneumonia and die. Now, does that mean that grandma is neurotic? Maybe, but not necessarily. Why? And it really is that grandmother generation. It's really the end. My moms don't worry so much about that. But why did grandma worry about you getting pneumonia and dying?
That was a real problem.
Yeah, because she grew up knowing people who died of pneumonia. In the 30s, 40s, 50s, pneumonia was a big killer in the world, especially in the United States. So that's why all this research was being done. Don't pick on grandma. She knows what she's doing. Usually. But Griffith was studying pneumonia. And in his studies, he wound up coming across two different types of bacteria. Two different strains of bacteria. Again, he's a physician, not a researcher, but that's his area of interest. So he didn't have big, fancy, sophisticated names for these bacteria. You're going to find out he named them based on what they look like. So he had one that he called smooth bacteria. Because when you grew it in a petri dish, this is our petri dish, bacterial colonies were all nice and symmetrical. They were smooth. Called them smooth bacteria. And what he found out is if he took that smooth bacteria and exposed mice to it, the mice died of pneumonia. And when we cultured bacteria out of their carcasses, there was lots of smooth bacteria. The other bacteria he had come across, he called rough for exactly the same reason. Because the colonies, the edges looked rough. So we had smooth bacteria, rough bacteria. Rough bacteria didn't cause any problems. You exposed the mice to rough bacteria, they didn't care. Well, the next thing he did was he killed the smooth bacteria. Killed it by passing it through a flame. and he found out that if you give the dead smooth bacteria to the mice are fine. They don't develop pneumonia, they're perfectly okay. And then what he did is kind of unique because he never really explains in his experimental procedure why he did this. Lots of people believe it was an accident. It was cross-contamination, and he then backwards engineered it and said, hey, guess what I found? Which wouldn't be a surprise, because that's how more than half of our discoveries in science happen. They happen, something's new, and then you go back and try to figure out how did this new happen. But what he did was he mixed the live rough and the smooth killed. Now, if you think of it, live rough, does that cause any problem? No. Killed smooth, does that cause any problem? No. But when he mixed them together, the mice got pneumonia and died. And when he cultured bacteria out of the mice, he found lots and lots and lots of live smooth bacteria. Yes?
Just a quick question. When he gave dead smooth bacteria to the mice, so they didn't get pneumonia, they didn't die, so he didn't reculture them out of their bodies?
Right.
Okay.
Well, actually, let me backtrack and say I'm not sure, to tell you the truth,
Okay.
because nobody's asked that question before. So I don't know, and I don't remember the literature well enough to know whether he cultured from the live animals as well. But this creates a problem for Griffith. Because, yes?
Why did all the smooth ones in the dead mice?
That's the question. That's exactly the question that's the problem he runs into. And there's only two ways that could happen. Either the dead bacteria came back to life, or somehow this live rough bacteria could be transformed into this smooth bacteria. Those are really his two options. One is that life comes from non-life, rising from the dead is possible. The other option is one living form can transform into another living form. Well, based on those two options, how many think living things rising from the dead is a logical explanation? How many think one life form transforming into another life form? That's what he thought as well. He said that one type of bacteria had been transformed into another. He was proposing that the live rough bacteria had somehow transformed into smooth bacteria. And the way he ventured to explain it is he said that something in that dead bacteria, there was some physical entity, some chemical, that the live bacteria could harvest from the dead bacteria and transform that rough bacteria into smooth bacteria. So he's making the proposition that who and what you are is actually a physical entity. It's a substance, a molecule, a collection of material that determines who and what you are. It's not, because if you think about it, in the 20s, what was the primary way people explained how you looked? Yep, in the late teens, even into the 20s. People assumed you looked the way you looked because why?
Your parents?
No, we didn't really think about your parents that much. Sort of, we knew it was a family resemblance.
Race.
No, it wasn't even race. Believe it or not, you looked the way you looked because that's the way God wanted you to look. And who and what you were was this mystical thing. It's really, when Griffith starts looking at it, he says, well, wait a minute, who and what you are is chemical like anything else. Which still becomes an interesting concept at the time, because you're going from a world where you and what you are is by divine speciality to now it's really just a collection of chemicals. There's really nothing special about you anyway. So that creates some issues. But he's the one who starts saying one transform. Now this doesn't say that people didn't say that parents gave you your looks, etc. In fact, even early back on, the first ideas with heredity was it was believed that the man gives you everything you need, your father determines everything about you, mom's just an oven that the cake bakes in until it's done. We now know that's not true, but back at the time that was the assumption. Was, it was the man's sperm that had everything that gave you life, and mom just carried you again, because, that's just the way women are. I didn't say this, women are going to be already happy by the end of time. But now we know much more, and obviously we know that it's actually the male that determines the gender of the child, which is kind of ironic when you think Henry VIII killed 4 of his wives because they wouldn't give him sons. And he had nothing to do, the women had nothing to do with him giving them sons. But he also killed a bunch of them because he was suffering from late-stage syphilis, and late-stage syphilis rots your brain away. Which is why there's so many wars in Europe in the Middle Ages, because they all had late-stage syphilis and they're all going crazy.